When will this bloody madman show up? I am sick and tired of his chemical riddles and nonsense. We should be out hunting him down, right at this moment.
Patience, my Dimitri. Our mission is of utmost importance. Do not forget what happened on the 5th of November.
Bah, when you're right, you're right. It's you! Calcium, krypton, cordite. Before you, a cantankerous chemist of catastrophic concoctions. A clamorous kook capable of kindling calamities kept under castles and keeps. Before cataclysmic kabooms, an archaic and alchemical mind stands in your presence. You may call me K. If you wish to save your precious settlement from ruin, then allow me to introduce the stakes. Riddle me this. A violet crystal awaits its half-death execution before the judge of light. The clock ticks by, but each half-death repeats again and again. The judge of light runs after the crystal at lengths of billions of a meter over waves, before catching it at a peak. Discover the half-death, and you will find the code and time before your little town is torn asunder. Very well. We will play our games, madman, but hear me now. We will hunt you down to the ends of time. I swear it!
To the laboratory! I have a hunch that will help us solve his riddle.
Are you insane? We do not have time to dabble in your experiments.
Trust. It will be a simple matter.
I don't want to live anymore!
No, Dimitri!
Just kidding.
From what I remember of general chemistry in college, there's a molecule known as crystal violet, sensitive to changes in pH. Initially, crystal violet has 4 stable resonance structures that interact with light in such a way to produce a characteristic violet color. With the addition of the hydroxide ion, all 4 structures would conform to a single stable non-resonant structure that does not interact with light. The solution subsequently becomes clear over a period of time. The speed of the reaction is determined by a rate constant. This characteristic rate constant we can calculate. That is the answer to K's riddle. Our first step shall be to initiate the calibration process. Hand me the spectrometer, please. Now, be sure to wait 3 minutes before adding the blank cuvette.
I will prepare the computer, sir.
Remember to wipe the exterior, too.
Here it is, the blank cuvette solution.
Now it is necessary to generate a spectrum of the crystal violet solution. Have you prepared the 2.0 times 10 to the negative 5 molar solution?
Yes, sir. It's right here.
Thank you.
We shall defeat this sinister chemist.
Indeed.
I will be sure to wipe it again.
Excellent work.
There it is! It's the maximum wavelength! Configure the computer immediately.
Yes. So it has been done. Remember, you have to wait 3 minutes before obtaining the precious data. Otherwise, the reaction will not proceed correctly.
Here I will be combining the sodium hydroxide solution with the crystal violet solution. Then we can proceed on to the reaction in which we find the equilibrium constant.
Excellent. It's coming along nicely.
The reaction is proceeding, but we must wait another 3 minutes so that the reaction can stabilize and the decomposition, hydroxylation of the reaction can occur.
After, you must remember to continue to place the cuvette into the spectrometer at 1 minute intervals. Then remove it quickly, otherwise it will heat up.
The reaction has proceeded correctly. After the 3 minutes, I will now remove the cuvette. I will fill it up 3/4 of the way full in order to allow proper readings for correct data.
Yes, we will vanquish our foe.
We must be
With
as
science.
precise as possible.
Excellent! Our data graph is complete. Now we only have to calculate the equilibrium constants to reveal the location of the bomb. Proceed!
I have the answer. Let's go. The bomb! I'm gonna start putting in the code.
And that's why you always wear goggles.